Hi, everyone. Thanks, Andrew, for the introduction. So as you said, my name is Faraz. I'm actually a fourth-year PhD student. That bio is a little bit out of date. Sorry about that. So today we'll be talking about MacroBase, and this will be a 90-minute workshop where hopefully you guys will get the chance to play with MacroBase yourselves, see why it's such a cool tool and why it's so useful for all these data scientists, all you folks out there. As I walk through these slides, the way I'll structure this talk is I'll spend the first 45 minutes or so going through the slides and explaining what MacroBase is and why it's useful. And then the second half, I'll let you guys play with it. And I've put up a link where you can download these workshop materials that you'll use in the second half. Just go to that URL right there. The one prerequisite is that you will need Java 8 to run the workshop materials. MacroBase is built on Java. So if you don't have that, unfortunately, there's not much you can do, I guess, but we can work out something, hopefully. Docker might, well, actually, yeah, that's true. Docker might work. Yeah, that's true. That's a good point. I can show you the Docker installation instructions there too. But yeah, regardless, go ahead and try to download that. If it doesn't work for whatever reason, I also have a USB drive that has the materials, and I'll go ahead and pass that around now in case the download link doesn't work. Could you go ahead and pass that around? Thanks. But yeah, I'll go ahead and go start through the slides. And feel free to raise your hand throughout, ask me any questions. I'd like to keep this interactive, and so if something comes up and it's confusing, feel free to raise your hand and I'll stop and explain. So, yeah. So MacroBase has been a multi-year effort that's involved a lot of people. Been a very collaborative effort. So here's the team: two of my advisors, Professor Peter Bayless and Matej Zaharia, along with a slew of PhD students, even an undergrad. And if you're curious, you can check out macrobase.stanford.edu for more information. But suffice it to say, this has been a multi-year effort, and we're really proud of the work that we've done. So the motivation behind MacroBase is that, as you guys know, since you're here at ODSC, big data is all the rage these days. And a big reason why data volumes are growing so rapidly is because monitoring and telemetry has become such an important use case for so many companies, right? And it's because companies these days need the ability to monitor these complex applications that rely on sensors, distributed processes out in the wild, production telemetry that's part of their applications. This is all part and parcel of the big data ecosystem now. And because storage costs have dropped so dramatically in the last few years, thanks to all these tools like S3 and HDFS and Kafka, and of course the rise of cloud computing, today in Silicon Valley, if you talk to companies like Microsoft, Facebook, Twitter, LinkedIn, what they'll tell you is that they're collecting on average 80 million events per second today, right? Which is an enormous amount of data, right? And because they're collecting so much data, they're logging this stuff constantly, they naturally have to ask their data scientists to monitor all this data that's being ingested. So what do these current monitoring pipelines look like? Well, they look something like this, right? So you've got all these ingest streams, right? Maybe you're recording videos in your application, maybe you have a data center, maybe you've put sensors in a car, and all of these different endpoints are collecting data, right? So you have some system for collecting and processing that data, cleaning it, messaging it, queuing it, batching it, storing it in some data warehouse, right? So you store it in the data warehouse, and at the same time, you try to build some visualization layer on top, some type of dashboarding system that lets you see at a high level what's happening, right? And once you've built that dashboarding system, you've naturally probably defined some kind of alerts, some set of rules, some set of notifications that will tell you, oh, hey, this failed. This data warehouse is down. These set of cars aren't working anymore. This video stream has stopped, collecting images. So you must do something, right? And the data analyst is the one who sits at the very end of this entire pipeline. And what she's typically doing is she's sitting at the end, she's waiting for some alert to fire. And then once that alert fires, she enters this reactive mode where she has to say, oh, okay, I have to debug what just happened. So she might look at the dashboard, she might customize the dashboard a little bit, then she might dig deeper and drill down into the data warehouse itself and see what's really happening, at a very, very fine-grained level. But this process is normally very, very tedious and very, very difficult, right? It takes usually, days, weeks for a data analyst to debug what happened in a particular data warehouse or what happened for a particular set of cars, right? And the truth is, if you talk to the top Silicon Valley companies, what they'll tell you is that on average, less than 6% of this data is actually read, right? So of the 80 million events per second that Microsoft, Facebook, Twitter, LinkedIn, and of course all these companies, not just those four, of that 80 million events per second, less than 6% is actually being looked at, right? Which is really kind of disappointing, right? Because what the big data promise kind of tells us, right, it gives us this idea that, okay, if you collect enough data, you should be able to extract value from that data and help move your bottom line, right? Improve your application, right? Make your production environment better for you, better for your ecosystem. But how can we really say that if only 6% of that data is actually being looked at and analyzed? So this poses, I think, a really important question for all of us, right? How can we actually take all this data and make some use of it and actually extract the value that we want to extract from it, right? How can we enable more productive, better, more automated analyses to efficiently monitor all of this data and telemetry at scale so that we can actually get that value that we want, right? So if you look again at that same diagram that I showed you a couple slides earlier, really the key bottleneck in all of this isn't the machines, it's the human, right? And it's the human's attention, right? It turns out that actually in this entire pipeline, human attention is the scarcest resource, right? It's infeasible to expect any data scientist to manually inspect these massive amounts of data, right? These large volumes that we're constantly collecting, 80 million events per second, there's no way that a human can keep up with that, right? And if you look at these current monitoring pipelines, the entire big data ecosystem, right? All of these companies here at this conference, they have spent their entire time building solutions for everything downstream of the data analyst, right? So we've got all of these tools that are really, really good at processing the data, collecting the data, querying the data, but we don't know what to query when, say, a data warehouse goes down, right? It becomes a really challenging question for the data scientist to figure out, okay, how should I actually debug this once I know that a failure occurs, right? And these tools don't really help you with, okay, here's the query that I should write. They give you the ability to write queries, but you have no idea as a data scientist where you should start. And normally what ends up happening is the data scientist has to use their own intuition, which is a good place to start, but usually is inefficient, unfortunately. Right? So what you could do is you could, take a stats textbook, take a machine learning textbook, read up on, kernel density estimation or PCA or all the techniques that are being talked about at this conference, and you could say, okay, I think I should try this to solve this particular problem, right? But the truth is, these textbooks are chock full of algorithms, but none of these algorithms are actually tried and tested, right? They're not actually built to work at scale, and it's very difficult to build the intuition for when you should actually use these algorithms to apply to a particular situation, right? So what we need some sort of system that can compose efficient, high-level statistical operators so that it can meaningfully extract the data that you need and figure out what's actually going on in your system and help you monitor all the data that's being ingested. So that's what MacroBase effectively is, right? If you look back at this monitoring pipeline, it's MacroBase that's sitting side by side with the data analyst and helping her figure out, here is the data that's most interesting, here's the trend that you need to pay attention to, here's what might be causing that failure, why that alert was triggered, right? That's the job of MacroBase. All right. And so the one-sentence summary is MacroBase is an analytic engine that tries to prioritize the data analyst's attention by finding explanations to highlight important trends in large-scale data sets, right? And so in this workshop, what I'll do is I'm going to demo the usage of MacroBase. I'll describe its architecture, how it works, at not a super low level, but enough detail that you can understand what's actually happening underneath the hood. And then hopefully, in the second half of this talk, I'll let you guys analyze some real-world data with MacroBase. And then if you have enough time, you can actually play with MacroBase on your own data sets and uncover maybe interesting trends that you hadn't seen before. So this is the rest of my talk. I'm going to walk through MacroBase. I'll do a short demo to show you guys how it works. I'll talk about the architecture and usage. And then, again, towards the end, I'll let you guys play with MacroBase yourself, and hopefully you'll love it as much as I do by the end. Any questions so far? Yeah, go ahead.
I'm not sure if this is the right one to ask this, but what kind of licensing does MacroBase have?
Oh, Apache 2. Yeah, so it's not restrictive at all. You can use it. You should be able to use it. If not, don't worry. It shouldn't be a problem. Yeah. Any other questions? Okay, cool. So to illustrate the power of MacroBase, I want to outline to you a scenario that I'm sure you guys are pretty familiar with. Okay, let's say you're a mobile app developer and you have released the newest version of your application, and now you're waiting for the logs to come in, and you want to debug any issues that might come up. And of course, you notice that some of the users that are using mobile application are having some problems, right? And this application of yours, it tends to consume lots of battery, and so one of the metrics that you track a lot is battery drain. And these three phones are reporting really, really high battery drain in your logs, right? So let's say I've got input data that looks like this, right? So I've stored some records, I have user IDs, I'm logging some basic information. I'm logging the state that the user's living in, I'm logging the hardware make, the hardware model, I'm also logging the firmware version of the device that the application's running on, and then I'm logging the version of my app, and of course my battery drain, okay? So what I'm going to do is I'm going to import this into MacroBase, and I'm going to query to see what might be causing it, okay? So this is how MacroBase works at a high level, right? The goal here is I want to explain what's causing the high battery drain. And the way that you do this in MacroBase is you write what's called a MacroBase SQL query. So what we've built is we've built an engine that functions like SQL. It functions like an OLAP database, but it has some tweaks that are MacroBase specific that lets you express queries in a pretty easy way, but gives you a lot of interesting results that a normal SQL database wouldn't give you, right? So let's build up a sample query that illustrates how you would use MacroBase, okay? So I've got my input data, I've got this table in the corner, and what I'm going to write as my SQL query is I'm going to write select star from diff. So this diff operator, this diff query, that is the unique MacroBase operator that gives you the functionality that MacroBase provides. That's how you can tap into MacroBase. If you run MacroBase, and I'll show you in just a second, it really is just basic SQL, but it's got these newer operators like diff. And the way that diff works is it takes in two tables. It takes in the outliers table and the inliers table. And so what I've done is I've written two subqueries to specify my outliers and inliers, right? So I've said, okay, I'm going to select star from mobile data, and I'm going to filter out everything that's high battery drain. Filter everything that's low battery drain, so the only thing that remains is high battery drain, right? Those are going to be my outliers. And then for my inliers, that second table, I'm going to keep everything that's low battery drain. And so what this diff operator is going to do is it's going to take these two tables, the outliers and inliers, and it's going to say, well, what's different? What's different in the outliers table that's not in the inliers table, right? So basically what MacroBase is doing is it's taking a statistical approach to finding the explanations, right? You want to explain high battery drain. So what I'm going to do is I'm going to find highly correlated features in my data that are present in the outliers table, in the high battery drain table, but are not present or very unlikely to be found in the inliers table. And that's the basics of MacroBase. That's what it's doing at a high level, right? Now, it's trying to find these features, but you have to define the feature space for what MacroBase wants to look at. So what you can do is you can say, okay, I want to look at these particular attributes, these particular columns in my table. I want to look at the hardware make, the hardware model, I want to look at the firmware version, and also the app version as well, right? So these are the explanation attributes, okay? So once I've constructed this query and I run it, right, that's the query end to end, pretty simple. What it will return to me is a table of results that looks something like this, right? So now I've got my four attributes, app version, hardware make, hardware model, and firmware version. And then I've got these two additional columns that are on the side that are basically metrics about these explanations, right? Support and relative risk. And I'll explain them in just a second. So a single row in this table, in this output table, is an explanation for high battery drain, right? It says that iPhone 8 is a likely cause of high battery drain. This is highly correlated, this attribute value combination is highly correlated with battery drain, with high battery drain, right? Now, to give you an idea of how much of an explanation it is, of how powerful that explanation is, we've got these metrics on the side. So what the support metric is telling you, and this support idea comes from data mining research. Support is a common way to talk about frequency, basically, or relative frequency. And so what the support is saying here is, how often does this explanation show up in my outliers table, right? So it turns out that in this table right here, where I wrote the subquery that had the battery drain greater than 0.9, 100% of the time, iPhone 8 showed up, right? And then that second column, the relative risk, is basically a measure of how likely the explanation occurred in the outliers versus the inliers, right? So iPhone 8 was 102 times more likely to show up in the high battery drain case than the low battery drain case, right? That's what that 102 value means, okay? Does that make sense to everyone? Cool, okay. So if you don't believe me, I'm going to show you right now how it actually works. So let me go ahead and go to my terminal, all right? So I'm going to run MacroBase SQL from the command line, all right? And I've got some pre-written queries that I'm going to copy in. So this is how you use MacroBase, right? You start this REPL, this SQL shell. So if you've used SQLite, used Postgres, used MySQL, it's basically the same thing, right? Just type in bin MacroBase SQL from that top level directory and you've got MacroBase ready to run. I'm going to load in my data from a CSV file. So this is the same data that I showed you earlier on the slide, right? As you can tell, it's got those same attributes. There's a couple here that are extra that I didn't really talk about, like average temperature, but ignore that for now. And I'm going to go ahead and run that exact same query that I talked about on the slide. So I'm going to copy it in here. And I get back the same results, right? I get back iPhone 8, I get back the version 50, I get back Apple, and I get back 4.4.1, right? So this is telling me that these are the things that are likely to cause my application to go haywire and drain the battery. Yeah?
So how many databases support?
How many databases? Yeah. So anything that can be connected over JDBC, we support. Yeah, because it's written in Java. Okay, so this is cool, right? I found out that, okay, iPhone 8 seems to be a cause, Apple seems to be the problem, you know, this firmware version seems to be a really big issue, and app version 50 is also causing me problems too. But, okay, it says that I'm 100 times more likely, right? One thing that's cool about MacroBase is that these ratios, these statistics that are on the side, like support and global ratio, are actually knobs that I can tune. So let's say that, you know what, 100 is not really good enough for me. I want something that's more than 100, okay? So here's what I'll do. I'm going to edit my previous query. I'm going to type in with min ratio 200.0. Okay? And so now what I found is actually the thing that's really interesting is it's not just a single attribute, it's the pair of attributes, right? It's iPhone 8 combined with version 4.4.1. It's Apple combined with firmware version 4.4.1. And it's version 50 of my app combined with the firmware version, right? And I've got the support metrics here again, and I've got the global ratio. Now this is 290 times more likely. So MacroBase isn't just finding single attributes, single features that might be the cause of the problem. It's also looking at combinations as well. And it can explore these combinations very efficiently. 2-order, 3-order, however much you'd like, MacroBase can handle, right? We optimize for lower order combinations like 2 and 3, but there's nothing stopping you from exploring whatever combination of attributes that you need. And this, I think, is the really nice thing that MacroBase does that a lot of other existing tools don't do, is that it's able to explore those higher order combinations, those needles in the haystack that would be really hard for you as a data scientist to find, without spending hours and hours running that query, right? This table isn't huge. It's only 100,000 rows, but it was able to do this in less than 40 milliseconds, right? And the thing that's, I think, really cool about this is that I've talked to data scientists at really, really big companies, right, here in Silicon Valley. And the way that they would normally solve this problem is that they would build a dashboard that examines every single one of these possible combinations, right? They would examine every single combination of hardware model and hardware make, firmware version and app version. And they would ask their data scientists to drill down one at a time in this huge hierarchy of combinations to figure out what's the cause. And MacroBase does this in a matter of seconds, actually less than a second, less than 50 milliseconds. So that is really the thing that's really cool about this tool. Yeah. Any questions? Yeah?
Does it have to be categorical data, or can it handle the weird?
That's a great question, and that's the question that I get all the time. So he asked, does it only handle categorical data, or can it also handle numerical features as well? So the truth is that right now it only supports categorical data. So the numerical support is something we're actively working on. We want to extend this. I think a really big challenge in this space is finding how to discretize that data, find like the range of values that makes sense here, because the problem is essentially infinitely complicated. And so what we did for at least a first pass is focus strictly on categorical attributes. But we're working on that as well. Yeah. Mm-hmm.
So just a question, because you selected certain categories.
Yeah.
Why not all categories?
Oh, yeah, that's a great point. You could do that. Instead of doing this, I could change it to on star. Yeah. And it gave you back my original stuff. This time it included the state. So I omitted state before for the sake of simplicity, but I put state here. It turns out that state is kind of useless in this case. There's no results. Yeah. Yeah. Great question. Great question. Yeah. Any other questions? Yeah, go ahead.
You mentioned Apache license. Does this work with Hadoop?
So the question was, does it work with Hadoop? Are you saying, can you use HDFS as a data ingest source? Yes, you should be able to. Yes, because Hadoop is, you can also connect over JDBC. I believe it should work. Yeah. Yeah. Yeah, another question?
Has this been deployed in any commercial environments?
Yes, it has. So the truth is, I'm not... Actually, you know what? There is one use case that I can talk about. There's a couple that I can't, unfortunately. Hopefully, we should be able to disclose that soon. But I will talk about one commercial use case in just a couple of slides. Yeah. Cool. Any other questions? Okay, so let me talk about that commercial use case. All right, let me go back to my PowerPoint slides. Okay, so hopefully that gave you at least some idea of how MacroBase works. Hopefully it's whet your appetite a little bit. You're a little bit excited about using this now. Let me talk about this commercial use case. So we worked with this company called Cambridge Mobile Telematics. And what CMT tries to do is they monitor driving behavior via a smartphone application. They ask their users to download an iPhone app or an Android app, and they're tracking their driving behavior and telling them like, hey, you know what, you're a little bit reckless on this highway. You should kind of slow down here, right? That's the kind of the basic gist of what CMT tries to do. And the question that they pose to us is this application behaving correctly on every single platform, right? Now, CMT was started by a bunch of MIT professors, right? And they know what they're doing. They're a pretty smart group. But this problem, this question right here, is a really hard one to answer, right? Because imagine if you just look at the case for Android. Well, the case for Android is just infinitely complicated. There's all sorts of combinations, right? I mean, this is just unbelievably convoluted. And if you wanted to actually spend time, answering this, if you spent just a single second trying to look at every combination of Android device, firmware version, OS version, location, it would take you probably a week, right? It would at least a week to figure out which applications are behaving correctly on which platforms, right? It's just too complicated. The space is too vast, right? Now, when we ran a MacroBase query on this data set that CMT gave us, what we found actually is that a particular beta version of iOS 9.0, beta 1-5, had a buggy Bluetooth stack. And that Bluetooth stack that was buggy prevented the iOS devices from connecting to a device that was in the car that was actually collecting the telemetry, right? So CMT has an iPhone app and it also has a sensor in the car and it connects over Bluetooth. Because of MacroBase, right, what would have taken CMT's data scientists a week at least to find, they found it in a matter of seconds. Yeah. And we've applied the same type of analysis, not just to CMT, we've also applied it to different time series domains commercially, comparing, days over days, weeks over weeks, months over months. The really nice thing about this tool is that it's pretty generalizable, right? That these statistics that we're collecting, like relative risk and support, they actually generalize quite well to lots of different applications, not just monitoring and debugging, but also any kind of time series, any kind of windowed analysis. It works quite well. Yeah. Okay. So now let me tell you about the architecture of MacroBase, how it works underneath the hood. I've given you an idea of what the interface is. Let's talk about how it actually works. So the way conceptually you want to think about MacroBase is that it's a series of operator cascades. Okay, and you execute these operator cascades to transform your data and then classify it, segment it into outliers, inliers, and then aggregate the streams by finding explanations that are responsible for a portion of the outliers and not the inliers, basically, right? So it looks something like this. You've got your transform step that segments your data into some set of categorical features, ideally. You've got some classification step that says here are the outliers, here are the inliers. And then you've got your explain step, right? So this TCE pattern, that's the heart of the MacroBase pipeline. Yeah. So let's talk about the transformation step. So this step is not actually a requirement. What I showed you in the demo briefly didn't really have any transformation. I wasn't applying any UDFs, for example. I wasn't transforming or munging or data cleaning my data at all. But this is something that, when we talk to folks out in industry, they said, well, okay, I'd like to apply some kind of dimensionality reduction to my data set first, right? Or I'd like to, apply some image-specified features, right? And you can do that. You can do that domain-specific processing in MacroBase. Really, it's just a set of Java APIs that you can implement, and MacroBase will take care of it for you, right? So you can combine and chain many transformations to build some kind of complex feature set as well. And then the classify stage, right? The goal is to segment and filter, some stream by a target behavior, like find the abnormalities, right? Now, in this case, when I wrote the diff query, I specified explicitly what I want my outliers and inliers to be, right? Now, we've also actually added a couple of, more advanced techniques for doing this, because in high-dimensional cases, it might be very hard to segment your data into outliers and inliers. And so the default is an unsupervised density estimation, where we basically use kernel density estimation, which is illustrated right here, to say, well, I think this is the point where there's a very high density or a very low density, depending on what you want. And so this will be my outlier range, and the rest will be my inliers. Right? But again, you can combine this with thresholds, predicates, or some kind of custom classifier. Yeah. And then the explain stage, this is the one that I think is probably the most important because this requires a little bit of information about how MacroBase is classifying and calculating the relative risk in the support, right? So imagine, for example, I've done my transformation, I've done my classification stage, and so now I've segmented my data into errors and non-errors. And let's say that I've got this stuff going on here. I've got a bunch of examples of errors. I've got a bunch of examples of non-errors. And so, if you eyeball this right away, what you might realize is that Canada is probably, at fault here because it never shows up in the non-errors case, but it's only showing up in the errors, right? Something is wrong with Canada in this particular example, right? So what we do is we calculate what's called the relative risk, right? Which is a technique that we've borrowed actually from epidemiologists where they measure the lift of certain diseases in a target population. We're applying that same idea here, right? So what we're doing is we're calculating the probability of an error conditioned on a certain attribute, in this case Canada, versus the probability of the error conditioned on not Canada, right? That's what the relative risk is calculating, right? Now what this translates to is actually something pretty simple, right? You just basically calculate a couple of ratios, right? And so in the example that I showed you, it's actually going to be 5, which in this situation would be an example of a high ratio, right? So the nice thing about this is that even though these concepts seem complicated, they're actually very, very straightforward to understand. It's easy for you to calculate them yourself, and it's easy to verify that MacroBase is doing the right thing. Okay, so that's MacroBase in a nutshell, right? This TCE pattern, transform, classify, and explain. Any questions? Okay, cool. So if you do have questions and you're just too shy to ask, there's a ton of research, ton of published work that we've had over the last couple of years. And you can also check out our blog posts at this URL right there. MacroBase is part of this broader 5-year effort called the Stanford Dawn Project, where we're trying to make machine learning and data science more usable. And so as we work on all of these different research projects, we publish our work at this URL where we have a blog that catalogs all the things that we're working on. So if you're curious, feel free to check it out. And you can read more about how we've extended MacroBase to do interesting thresholding, do interesting things with time series. We've also looked at how to implement different types of sketching algorithms so you can handle quantile queries really efficiently over large data sets. And you can also look at the architecture of how MacroBase SQL works too. Yeah. Okay. So with that, I think it's time to let you guys unleash yourselves on MacroBase and see what you guys can do with it. So if you remember, I gave you guys a URL at the very beginning. Now these steps you can go through if you want to go sort of step by step. This is kind of the version 0 of the tutorial. But if you followed the URL at the very beginning of this talk, here I'll go back to the slides. Go back to that first slide. If you just download the stuff that's at this URL, the materials here, that should give you everything you need to work through the tutorial. Okay? Let me go back real quick. Yeah. Okay. And then once you've downloaded those materials, you can get started by just running MacroBase SQL from the top level directory, so bin/MacroBase SQL. And I'll go over a little bit what the tutorial task is so that you guys can have some sense of what's going on. So the idea is that we're going to be analyzing some Wikipedia edit data. So in the materials, I've given you guys a sample data set. It's called wikiticker.csv. And this Wikipedia data set has a bunch of attributes, a bunch of categorical features, like page and channel and namespace and comment and metric code, etc. And it's also got several interesting metrics that you can look at. So things like added, number of lines added, number of lines deleted, number of lines delta total that were changed in a given edit. And this is, I think a good way for you guys to see how MacroBase works on a real data set, right? And so to get started, if you look in the materials, if you've downloaded them already, there's a HTML file that's, I think, called MacroBase tutorial that has all this stuff. This is kind of like the starting point where you take that file and you import it into the MacroBase shell once you've run it. But if you have the time now, go ahead and start working with this. I'll start walking around and helping you guys. And feel free to raise your hand if you have any questions. And yeah, I'm happy to help.